And maths C.
C. Okay, tak apa. Memang macam tu lah.
Maths A minus.
Oh, maths A minus. Oh, very good, very good. Right,
So
let's. Ah,
actually last week only get all, so I forget to send. This week I will send all the questions to you.
yeah. You send me. I want to see.
Okay, sir.
Okay, right. Okay. So now, Kepler's law. Okay. Very easy subtopic like this one. Okay, what you need to know from this subtopic, you must able to explain all three Kepler's law. Kepler's law ni ada tiga Kepler lah. Kepler first law, Kepler second law, Kepler third law. You must know how to describe each law. And then secondly, you must know how to express Kepler's third law. Express means in an equation. In an equation. And then solve the problem using the Kepler's third law. Because first and second mostly not so related with the equation or calculation. Third law only we have a third law baru kita ada equation. Okay, let's see Kepler's first law. Okay, what Kepler's first law mentioned to us? All planets move in elliptical orbit with the sun at one focus. All planet move in elliptical. Apa tu elliptical? Okay, kalau dia macam ni, dia betul-betul bulat. Dia elliptical ni more towards like you have something like bujur lah, like this. Here, this is a elliptical shape. Okay, elliptical shape, they don't have the same radius. Okay, we cannot call it radius first of all. Okay, the normally the this one, you see the blue color one, we call this one is a major axis, and vertical one we call minor axis. Normally major axis must be greater than minor axis. Okay, this is the shape what we call as a elliptical shape. Okay, so all the planet will revolve around the sun. So sun must be the focus, at one focus. Every berpusat pada matahari sahaja. Every planet. Okay, so dalam elliptical shape ni kita ada dua point. Okay, first one is the perihelion point, and the second one is aphelion point. Perihelion point maksudnya a place where the planet is closest to the sun. For example, our earth here is very close to the sun at this point. Okay, at this point. So this point we known as a perihelion point. Okay, whereas we have the aphelion point, where the place is the point is the farthest. Farthest means yang paling jauh dari matahari. Okay, so this is what the Kepler's first law mentioned to us. Okay, the planet in the solar system have elliptical shape orbit, just like this, and sun always stay on the focus of the ellipse. Okay, shape dia ellipse, berbentuk, jadi kita cakap elliptical. Okay, right. So that's the Kepler's first law explained to us. Not only that, okay, we have a few more. The major axis always longer than the minor axis. Nama pun dah major kan? Okay, so major axis always longer than the minor axis. And what else we need to know? Most orbit of planet in the solar system have major axis and minor axis at almost the same length. Almost the same length. They have these major and minor axis. Maksudnya planet lain pun it will having the same major and minor length. Okay, almost the same lah. But it will be, although it almost the same slightly, the major axis must be longer than minor axis in each orbit for the planet. And planet can be assumed to make a circular motion around the sun. Okay, when we calculate, kita akan guna 2 pi r lah when we calculate, because we assume it is a circle, because ellipse, we don't use the ellipse equation to calculate. Okay, so that's why we assume a circular motion. Okay, the radius of the orbit is the average value of the distance between the planet and the sun. Okay, we calculate the distance between planet and the sun. Kita ambil dia punya radius of the orbit. Okay, for example, kamu tengok, kita ada Earth dan Sun kan. The distance between these two body is known as the radius of the orbital Earth. Radius of orbit. Okay, kamu akan perasankan biasanya dia punya radius mesti dari center baru sampai ke circumference kan, radius. Tapi this is not circle. We just assume only. So we will assume the distance between the two, the distance between the sun and any planet is the radius of the orbit. Okay, kena ingat yang tu maksudnya radius, orbital radius. Okay, right. Kepler's first law faham tak semua dah?
Faham, sir.
Okay, let's go to the next one. Kepler's second law. Okay, Kepler's second law ataupun kita panggil law of areas lah. Okay, a line that connect a planet to the sun sweeps out equal area in equal time. Okay, a line that connect a planet to the sun sweep out equal areas in equal time. Apa maksud dia? Okay, for the first glance you might not understanding. Okay, let us go through with this. Okay, let's say you have the sun here. Okay, so we have a line. Okay, line that connect a planet to the sun. Okay, it's like the radius lah. Okay, you can see this line connect to the sun at 2 point here. Okay, so we take this from A, it going to B, we will tell A to B lah, and C going to D, like this part. Okay, right, we have AB and CD lah sekarang. So why we assume AB and CD to be the same? Because kita kan assume bahawa this is the orbital radius. Betul. The sun, when your earth come at this place A to B, here also radius, right? So we will assume the time taken for the earth to revolve around A to B dengan C to D is equal. Okay, kena ingat first the time is equal. That means area 1 and area 2 should be equal. Why I put AFB and CFD? Because sun is the focus. Sun is the focus. So kita letak F, AFB dengan CFD. Sebab yang ini bukan a perfect circle. Jadi kita kena buat andaian macam tu. We need to do this kind of assumption lah. Kalau circle biasa kan. Okay, kita cuba tengok circle biasa kita. Okay, ini radius, ini pun radius. Okay, kalau ini dengan yang ni dia sama angle kan. So the area should be equal. Okay, we will assume like that in a normal circle. But this is not a circle, this is an ellipse. So we assume like this. Kena buat assumption macam ni semua, baru kita boleh terima pakai Kepler's third law. Okay, jadi the time taken for the for the Earth or any planet move from A to B is also equal to the planet to move from C to D. So time A to B equal to C to D. That means the area 1 is equal to area 2. But however, we assume the time and area are equal. But then if you see CD covering more length, right? CD is covering more length compared to AB. Okay, CD is covering more length. So the linear speed C to D is greater than A to B. The speed is different. The speed of the planet revolving around will be different. Okay. Untuk faham benda ni, we just use the normal distance formula. Okay, velocity is equal to distance over time. Sekarang kita dah assume A to B and C to D will take the same time, right? So kalau apa-apa constant, kamu kena tinggal benda tu. Okay, so kita swap dulu. Dia akan jadi apa? Distance over velocity. Sebab T ni constant, jangan kacau dia. Okay, kita nak compare distance dengan velocity. Jadi kita compare A to B distance and C to D distance. Okay, A to B is shorter, C to D is covering more length, right? So when your distance meningkat, you punya velocity meningkat. So that's why when your CD is greater than AB, so your speed C to D greater than A to B. Your distance more, your velocity more. Can you understand this part? Why like that?
Understand, sir.
Okay, good. Since AB cover more distance compared to CD within the same time, at AB will be faster than CD. This one, sorry, typo error. This should be, since CD cover more distance compared to AB within the same time, so CD is faster than AB. Okay, yang tu tolong betulkan. Okay. Right. Sekarang kita dah faham apa itu. Okay, kita tengok balik So, a line that connect a planet to the sun sweep out the equal area in equal time. Okay. So, maksudnya line that connect to the planet to the sun, this one, when you have something like a curve like ABC, both must be having the equal area and equal time. Okay. Kita develop the Kepler's second law ni supaya dia hasilkan Kepler's third law. If we combine the Kepler first, Kepler 2 punya knowledge, lepas tu kita buat Kepler's third law. Okay, Kepler's third law simple saja. The square of period of any planet. Period ni kena tahu. Period ni maksudnya apa? Time taken by a planet to make a complete revolution. Peredaran, a complete revolution around the sun lah. Okay, like for Earth, right? Earth will take 365 days approximately. Okay, this is your sun. Earth will take 365 days approximately as the period. Okay, that is the period for the Earth. It will take 365 days. That's why we celebrate 1 year is 365 days. Not we simply choose 365 days. Apa kena mengena? Kenapa boleh jadikan 100 days saja 1 tahun kan? Tak boleh. Yang ni semua, the day, the months, yang ni semua kita buat berdasarkan peredaran the moon revolution and the earth revolution. Okay, it's not simply created the time, okay, and the space, all these things. When you can master the time, mass, all these kind of things, then you can understand like Albert Einstein's kita biasa kita tengok kan Hollywood movie, kita ada time travel punya story semua kan. It is It is not completely something that we cannot accept. If you understand about what is time, what is a space, then you will assume that this this time travel thing is something like we can create a good theory lah. But of course it will be theory because we cannot prove it. Okay. Kalau kita nak tahu logic behind the time travel all, you must master this kind of time and space relationship. So and also you must have this kind of mainly the time and space knowledge lah. It's full of we call apa ni, theory of relativity. If you can understand that, then you can create a modern device, and you can do a lot of things lah. Sometimes kita tak faham cerita tu sebab we are lack of knowledge. So this time is very important. Okay, right. Kenapa kita ada 4 tahun sekali ada apa ni, tahun lompat, yang tu semua dia ada calculation. Okay, because our earth not exactly 365 days. It's 365 1/4 days. At pada tahun keempat dia akan jadi 366 days. Sebab tu dia tahun lompat dia ada one day extra. Sebab it not exactly 365 days. 365 1/4 days. That's right. Okay. Now, simple saja, Kepler's third law. The square of period of any planet, that means period maksudnya T besar, square dia is proportional, ini simbol dia, proportional to the cube of the radius of its orbit. Radius of orbit R and cube it. Okay? Right. So, biasa kalau macam ni kan, kita akan cuba create a constant to make it equal. Ini first cara. Second, K ni constant kan. So, jadi kita boleh create macam ni. Dia, let's say kita ada T1 and then directly proportional, so we will divide lah R2, R1, T1 and R1, let's say a period and a radius 1. Okay, according to the Kepler, we square the period, we cube the radius. And we have another period, T2 and R2, which are directly proportional. And according to the Kepler, we need to square the period and then cube the radius. Both will be equal. Kenapa equal? Sebab tak kisah T square over okay, you analyze this situation. Apa itu K? When we make the K as a subject, it's a T square over R cube. So tak kisahlah apa T value you want to put, apa R value you want to put, it definitely equal to K. Jadi you punya T1 over R1 square cube is also equal to K, and your T2 over R2 you square and you cube also equal to K. So maka kita gabung equation ini, dia datanglah equation macam ni dulu. T1 square over R1 cube equal to T2 square over R2 cube. Lepas tu kita tolong arrange dia. For example, kamu boleh buat macam ni. You can make this come here. When you move this T towards here, dia akan jadi T1 square over T2 square equal to R1 cube over R2 cube. Terhasil formula macam ni. Okay. So it's full of maths. This is how we derive an equation. I repeat again. First, we get to know what is the Kepler's law. Third law. Dia cakap period square is proportional to the radius cube. Period square proportional to radius cube. Lepas tu kita hasilkan untuk dua value. T1 R1, lagi satu T2 R2. And kalau kita tengok, dua-dua pun equal to K because K is always constant. Jadi kita gabung dua-dua equation jadi macam ni. Kita arrange, kita dapat macam ni. Can understand?
Sir, apa beza T1 over R1 dengan T2 over R2?
Tak ada beza. Contoh contoh T1 ni kan, mungkin kita boleh dapat, okay, I just give you exposure lah. Satu analogy lah, okay. Mungkin T1 ni, dia value dia 10. Okay, T1 ni value dia 10. Tanpa square and cube, I cakap tanpa square and cube. Okay. Okay, never mind. Kita cuba buat. T1, let's say saya dapat 5. Untuk R1, saya dapat 10. Untuk T2, lagi satu, T2, let's say 20. And R2 dia, let's say 10, so 40. If let's say T1 divide R1, I get 1 over 2. And 20 over 40 also 1 over 2. Both also getting the same constant, right? Jadi T1 over R1 equal to T2 over R2. Kita boleh cakap macam tu. Saya ambil T1 punya value, R1 value, I still get K. See this one. T2 dengan R2 still dapat K. Kita buat simultaneous lah. Maksudnya T1 over R1 equal to T2 dengan R2. Because both also K equal to K, what? And then kita arrange je lah. T1 bawah dia jadikan T2. R1 atas, R2 bawah. Kita exchange. Dia lahir macam ni. It's just derivation. If you don't understand, it's okay. We just want to know this formula only. Okay? And kena ingat, R2 adalah distance from the sun to the other planet. Okay? To the other planet. Maksudnya, kamu punya, okay, T1 square dengan R1 cube, value yang dia ambil untuk pusing kan, revolve around the thing, all the orbit must be proportional only. Will be having the same thing only. Kalau radius dia meningkat, maka orbital orbital period dia pun akan meningkat. Kalau radius kecil, orbital period pun kecil. Dia akan dia kata like a uniform lah. Okay, proportional. Okay, right. We try out certain thing, then only we can understand this. Okay. So if anyone asks how to derive a Kepler law, macam tadi saya explain lah. Okay. So just for the derivation, how to derive that. I show you one more time. You can make use of this space below. Okay, derivation kan. Okay, first kamu baca dia punya law dulu. Dia cakap apa? T square, okay, period dia punya square is proportional to the radius dia punya cube. Jadi, let's say I have the first one. You see the green color radius? Green color orbit. Okay, we have the planet and then we have the R. So, for the green color one, I will use T1 over R1. Lepas tu, applying Kepler's law. Okay, before that, T square dari simbol directly proportional, kalau kita nak tukar sama juga, jadi kita kena ada satu constant. Saya panggil constant dia adalah K. Okay, KR cube. Okay, from here, okay, I show you step by step, so that you won't miss this thing. From here, jadikan K sebagai subjek. R cube ni kita bawa pergi sebelah kiri. Okay, nampak? Right. Sekarang, let's say we have this is unknown, right? Let's say I have a T1 with a value and R1 with a value. If I square this and cube this, apply the Kepler law, I will get K. I will get K. And I try it with another planet. Another planet also, we have a orbital period 2 and then the radius 2. Same thing, I apply Kepler, that is square the period, cube the radius. I again get the K. So, kita boleh buat rumusan, we can deduce that T1 square over R1 cube, which is equal to K, also equal to T2 over R2, square ke atas, cube ke bawah. Lepas tu, I try to arrange the equation for my own cita rasa lah. Actually, this equation is already correct. You want to understand until here only? Doesn't matter. Use that equation. It doesn't matter. Okay? Tak ada apa dah. Kamu boleh guna equation ini dah. So, saya nak bagi tahu how they get this equation. Okay? So, I switch place between these two. So, maka terhasillah formula ni. Now can understand better? Okay. Dah salin?
Dah salin.
Okay. Let's move on to the next one. Okay, kena faham formula ni dulu, baru kita nak. Sekarang, kita baru tahu the Kepler's third law. That means law of period lah. Okay. Now we want to express this Kepler's third law in a more meaningful way. Ini bukan meaningful lagi, ini just bagi tahu je kamu. Alright, sekarang expressing Kepler's third law. Okay. Kita tengok Okay, ingat sun to the distance of this planet should be the radius r, and when a planet is moving, it always have the v, the linear speed, and centripetal force jangan lupa always act towards the center. Okay, they are always point towards the center. Okay, sekarang saya nak buat beberapa quantity here. The big letter M, let's say it is the mass of the sun. The small letter m is the mass of the planet. Maybe Earth, maybe other planet. Okay, this v is actually the linear speed of the planet. And r tu adalah orbital radius. Dan yang terakhir T adalah period of the planet around the sun. Okay. Now, we start from here. Remember this formula all. distance travel by the planet in one complete circle. Kita assume elliptical tu sebagai circle. Saya tadi dah cakap. From the first law. Kita anggap sebagai circle. Jadi, the distance travel by the planet is the circumference formula lah, 2 pi r. Linear speed ni macam mana dia kira? Okay. Speed tu macam mana kita kira? Speed adalah distance over time. Okay. Distance yang diambil oleh planet adalah 2 pi r. And time taken to revolve, kita express with the big letter T. So, that's why you get linear speed is equal to 2 pi r over T. Okay. Now, I'm going to express this, I'm going to express, tadi saya bagi tahu kan, T square is equal to K R cube. Kita nak express this form lah, in a much meaningful way. Okay, macam mana? Another thought. See here. Gravitational force that act on a planet. Gravity punya formula apa dia, Safrina? F equal to?
G M1 M2 over R.
R apa?
R cube.
R square. R cube baru kita topik ni baru kita masuk R cube. Okay. Baik. Sekarang M1, M2 kita tak perlu cakap sebab saya dah cakap mass of the sun and mass of the planet kan tadi. Jadi big letter M, small letter m over R square. First equation. Okay, equation number 1. Lepas tu centripetal force. Your planet also exerting a centripetal force towards the center, which is the sun. So, apa formula untuk centripetal force?
MV square over R.
MV square over R. Very good. Okay, sekarang kamu boleh nampak equation 1 pun F, equation 2 pun F kan. Jadi, G M N over R square should be equal to MV square over R. Kenapa macam tu pula? Sebab dua-dua pun F. Your gravity is equal to centripetal force. Remember that. Okay? So, when you equate like this, any common point you can cut them off. Contoh kat atas, tengok denominator. Kita ada mass, small mass. 2 kali, kita potong. Radius, ini potong sekali. Ini daripada R square ni ada 2 R lah. Maksudnya kita potong 1 R, dia jadi R saja. Okay, kita kutip apa yang kita dapat. G M over R equal to V square. Okay. Kita ada apa? Tengok G M over R equal to V square. Kita kutip apa yang ada. Okay. Baik. Lepas tu kita jadi kompleks lagi. V kan kita tahu tadi. V itu apa dia? 2 pi R over T kan. We now want to replace already. Replace V with the 2 pi R over T. Maksudnya Gm over R is actually equal to 2 pi R over T square. Okay, let me write it properly. 2 pi R over T square. Sebab V is equal to 2 pi R over T kita ganti dia. Ganti V tu. Lepas tu, kita jadikan T square as a formula. Okay. Kamu tengok Dia ni kerja banyak sikit. Okay. Sebab derivation ni dia akan tanya dalam exam. This derivation must know. Lepas tu kita nak kita kembang dulu equation dia. Okay, the expansion I show outside of the box. So kita akan dapat Gm over R equal to 2 pi R square over T ni kita nak square. Jadi dia akan jadi 4 pi square R square over T square. Okay, lepas tu, okay, dah buat macam ni. I make the T as a subject. I make T as a subject. So, this whole GM over R, saya bawa dekat sini, bahagi. I swap place. Jadi dia akan jadi T square equal to 4 pi square R square bahagi GM over R. Faham dah yang ni? This part you understand?
Faham.
Faham. So 4 pi square R square bahagi pecahan kita jadi darab, terbalikkan pecahan. Jadi apa yang kita dapat? T square equal to 4 pi R square darab R. Maksudnya 4 pi square R square darab dengan R, dia akan jadi R cube over GM. Dia akan jadi macam tu. Okay. And remember our Kepler's third law? Kepler's third law. T square dengan R cube kita dapat balik. Okay. Maybe we are going to relate with that. Yes, we are going to do that. So, remember your Kepler's law. T square equal directly proportional to R cube. So, T square, kalau kita nak hilangkan proportional symbol, dah banyak kali bagi tahu, kita kena ada, you nak tukar jadi equal boleh, you kena tambah constant K. K is a constant. From Kepler's law, okay, from Kepler's law, kita dapat formula macam ni, K R cube. Lepas tu, from equating the gravity dengan centripetal force, kita pula dapat macam ni. T square equal to 4 pi R cube over GM. Saya asingkan macam ni dulu. Baru kita boleh tengok benda tu clearly. This equation I get from the Kepler's third law. This equation I get when your force of gravity is equal to centripetal force. And if you observe carefully, they're leading up the same thing. K is a constant. 4 ialah constant, memang 4. Pi ialah constant, tak akan berubah. Gravity punya constant tak akan berubah. Mass of the sun tak akan berubah. Semua ni constant. Dan semua constant ni kita boleh anggap sebagai K. Maka K itu adalah 4, saya lupa square tadi Ada square di sini. 4 pi square. So 4 pi square over GM is equal to K. Can understand?
Can, sir.
Okay. Right. So, simple saja. T square equal to KR cube is a simple formula. K tu constant dia boleh bawa dia punya value 4 pi square over GM. Okay. And remember, this M can be interchangeable. If applied to the planet and the sun, the big letter M is always the mass of the sun. Sometimes, we are not talking about the sun. It's like our Earth is the center, movement of satellite. So, if kalau kita nak tengok movement of satellite, Earth is the center, so your mass of the Earth will be the M. Kita pandai-pandai tukarlah. Whether it's a planet to sun or satellite to Earth. Kalau planet to sun, sun as the focus, so the big letter M should be mass of the sun. Kalau Earth dengan satellite, Earth is the center, jadi mass of the Earth will be the big letter M. You clear right until here?
Yes, sir.
Okay, good. Now, let's start. You need to understand all these things first, then only we can do the calculation part. Now, problem solving using Kepler's third law. Okay, how do we do that? You know already the formula. No need for me to repeat again. T1, kalau kamu tak faham formula arrange like this, you just like this. T1 over R1, T2 over R2. Period kena square, radius kena cube. Sudah cukup. Formula ni dah cukup. Mesti boleh dapat jawapan yang betul je. Tak perlu kamu kena ubah macam ni. Not compulsory. Okay, we just arrange the thing only. Right? So it doesn't matter. Okay. Okay. For planet ni dah bagi tahu For planet orbiting the sun, ini planet dengan sun, R is the distance between the center of the planet and the center of the sun. Mestilah the orbital radius lah. Okay. Kalau satellite dengan Earth, kan sometimes Earth di sini, satellite dia jauh sikit kan. So satellite dia mungkin jauh dari orbit tu, orbit yang biasa. So from here to here is the normal radius of the Earth, and then from here to here is the height. So the total radius kita kena ambil R plus H lah. Okay. Berapa lama satellite ni dia revolve. Okay, whenever it's a satellite, remember you need to take the radius of the Earth and the height of satellite from the Earth. Okay, next. So from here we can know one conclusion. A planet orbiting with a bigger radius of orbit has a bigger orbital period. Of course, kan T square over R cube, right? Okay, T square over R cube equal to K lah. K tu apa dia? 4 pi square over GM lah. Okay, right. So a planet with a bigger radius, that means kalau radius kamu meningkat, period kamu akan meningkat. Okay, the orbital period will be bigger or longer. It's supposed to be longer, right? Longer the orbital period. Okay, directly proportional. Okay, baik. Kita dah habis Kepler 1, Kepler 2, Kepler 3. But how to use this knowledge all to answer the question? That's the most important one. Okay, right. Let us see some calculation here. Okay. Baik, kamu tengok ada sun, ada planet 1, ada planet 2. Okay. Now, first question. State the position of the two focus point on the orbit. State the position of two focus point of the orbit. So, which one you will pick?
Which one means the A, B, C, D, E?
Which point? Yeah.
Planet 2, point A, planet 1, point E.
Planet 1, point A. But for
Focus point B. Focus point B.
Focus point B, right? One more. Kita ambil Kepler's first law dulu. Okay, kita ambil Kepler's first law. Okay. So, the sun always stay on a focus at the ellipse. Sun biasanya dia akan jadi fokus setiap kali. Okay.
Hmm.
Got anything else? No. Okay, from here they asking 2 points.
Ah.
I know B is one of the point. What will be the another point? The thing, the all the orbit radius should be proportional, right?
Hmm.
So kamu tengok dari B, okay, dari B, dia nak sampai, okay, dari B, okay, contoh kita ambil, uh, kita ambil dari planet satu. This much longer. Dari B ke E. Dari B ke E. Still not getting it. Dari B sampai ke E, yang point tengah-tengah should be D, right?
Oh.
So D is one of the focus. Okay, D is one of the focus. And then Sun memang dah ada dekat sini. Takkan A kot. Okay, so I just put B first. Another position, let us see why they asking another position. Okay, why I tell B? Because Sun always the focus, right?
Ah.
So kita guna law apa? Kepler's first law. Kepler's first law. Okay. Next, compare the speed of planet 1 when orbiting at point A and E. Okay, planet 1 sekarang dekat sini, titik dia dekat sini. So planet 1, dari planet 1 dia kena pergi ke point A, jauh macam ni, and we compare it with the point E like this. So kita boleh nampak the distance taken towards A is greater than the distance taken towards E. But the problem here, the time will be the same. Here dari planet satu ni, let's say X lah. Dari X to E or X to A, it will take the same time. So planet dari X dia nak pergi A tu, distance dia panjang. Jadi dia punya velocity pun kena high enough. Okay, dia punya velocity pun kena high enough at the A compared to the E. You understand my point here?
Understand, sir.
Okay, good. So, the speed, I just write at simple one. So, velocity, I put is like this lah. I put symbolic answer. Velocity at A should be greater than velocity at E. Kita guna what law? This is the law of area. Yang distance time tu semua, law of area, that is your Kepler's second law. Tak ada letak apostrophe S, kena potong markah. Mesti Kepler's second law. Tak boleh buat kesalahan ejaan juga yang berkaitan dengan law semua. Okay, now the question is, given that the orbital period is 2.3 years, okay, with the orbital radius of 1.8 times 10 to the power of 12 meter, if orbital of the second planet 2, 3.5 years, calculate its orbital radius. Okay, biasa period dia kena ada dalam bentuk second lah. Okay, dia kena ada dalam bentuk second. But this is going to cancel each other. So, it's okay one if you want to maintain in years. Okay, if you want to maintain in years, it doesn't matter. Because somehow you want to cut both things. Okay, like this lah. You use this formula. Saya ajar tadi tu. T1 over R1. T2 over R2. T1 ni untuk planet satu lah. T1 R1. T2 ni untuk planet yang kedua. Yang ni kita square. Ini kita cube. Square, kita cube. Okay. Kalau kamu tulis sekali nanti 1, 2, nanti 3, nanti kamu akan you will confuse. Why I put 1 here, why I put 2 here. So T1 R1, T2 R2. You do like that first, and then numerator you square, denominator you cube. Okay, untuk planet 1, the period is 2.3 year. Kamu nak tukar kepada second, leceh juga. Okay, tak payah sebab it is a proportional. Somehow years and years you want to cut off, so it doesn't matter. So 2.3 years untuk planet 1, dan orbital radius dia adalah 1.8 times 10 to the power of 12. And ini baru T1 dengan R1. Okay, sekarang jangan lupa yang ini kena square, yang ini kena cube. Equal to second period already given for the planet 3.5 square. And this will be your R what? I think Safrina, kita arrange the equation dulu. Sebab nanti dia bawa that day I already told right. What they ask, you make it as an object first. Okay, kita nak orbital radius for the second planet. Yang ni. Kalau kita arrange, dia akan jadi T2 square. Okay. This one, dia akan pergi sana tukar. Jadi dia akan jadi bahagi pula. Bahagi. Okay, I just show you lah. I think you all can do this one all. Okay. Bahagi T1 over T1 square bahagi R1 cube. So dia akan jadi darab terbalik. R1 cube over T1 square. And then and then this cube padam sebab kita nak orbital radius kan. Lepas tu jangan lupa you bagi cube root bagi answer ni. Okay, sekarang dah boleh cari R terus. Okay, kita ganti one by one. So T square dia T2 dia 3.5 years. And then square it. Times orbital radius bagi planet 1. 1.8 times 10 to the power of 12. Jangan lupa cube it. Over T1 square. T1 dia 2.3 years. So 2.3, jangan lupa square dia. Okay, how much you get?
2.3814 times 10 power 12.
Kamu ambil 3 significant figure sudah cukup.
2.38.
2.38 times 10 to the power of 12 meter. Okay. So it's a little bit like a lengthy way lah, but then this is the way. So what law we used just now? Kepler's third law. Okay, right. Next, question 2. Kena tulis kecil-kecil pula. Okay. Given that the orbital radius of the Earth and the mass, okay, are 1.5 and 2.28. I just read the in front part. If the orbital period of the Earth is 1 year, how long does it take for the mass to orbit the Sun? Okay. So kita compare Earth dengan Mars kan? Okay. Very simple. Okay, kita tulis dulu formula. T1 atau kamu nak letak Earth to E. Okay, letak macam ni dulu. T over R, T over R. Yang ni adalah untuk Earth. Yang ini untuk adalah mass. Also can. And then, jangan lupa kita kena square ke atas, cube ke bawah. Okay, apa yang dia tanya? How long does it take? Period of the mass. So, dia tanya Tm square lah. Okay, how long maksudnya period. Untuk apa? Mass. Dia tanya yang ni lah. Jadikan yang ni subjek. Jadi, kita bawa pergi sana. Jadi, Te square darab dengan R cube of the M bahagi RE cube. Lepas tu, kita akan dapat Tm. But, this is a squared formula. They want just the period. Just the T. Jadi, square ni kita kena bagi sana juga. Dia akan jadi square root lah. Baru complete formula dia. Okay. Sekarang kita ganti. Macam mana kita baca? Kita tengok. Period square of the earth. Period square of the earth. Earth ialah 1 year kan? So, 1 square. Darab radius of the mass. Radius of the mass is here. Okay, radius of the mass. This is the radius of the earth. Orbital radius of the mass is 2.28 times 10 to the power of 11. Jangan lupa untuk cube. Lepas tu, orbital radius for the earth. Catat ke bawah. 1.5 times 10 to the power of 11. Bracket dia, jangan lupa cube. Lepas tu, the whole answer, kamu jangan lupa square root. Berapa kamu dapat?
1.87.
1.87 times 1.87 only, right? 1.87 years lah. Sebab tadi kita ganti sebagai years kan sini. Itu cara kita buat. Okay? Right. One more question. One more question, then end ready the subtopic. Okay? After this, the exercise only lah. Okay. Kita buat exercise, baru kita boleh faham benda ni. Okay, next. The radius of the radius of orbital mass lah. Orbital of planet mass. Or radius of orbit. Okay. Can just put orbital radius. Okay. Radius of orbit of Mars is 2.28. Okay. Radius of a mass. And its orbital period. Period of the mass is 1.88 years. Calculate the radius of orbit of Jupiter. Dia tanya radius bagi Jupiter J if its orbital period, dia bagi orbital period maksudnya period T untuk Jupiter J is 11.9 years. Okay, kita susun dulu equation. Baik, kena buat secara sabar dulu. Okay, right, you letak T over R, T over R. Okay, T ni untuk siapa? Mass. Okay, so radius pun mass. T ni untuk Jupiter, so radius pun Jupiter. Okay, numerator kena square, denominator kena cube. Sekarang, apa yang kita nak cari? Kita nak cari calculate the radius of orbit of Jupiter. Maksudnya yang ni. Orbital radius of the Jupiter. Maksudnya kita kena switch place dekat sini. Maka dia akan bentuk macam ni Okay, your R J, saya letak cube sekejap je, nanti kita padam. Okay. So kita ada T square J yang ni. Lepas tu benda ni kita bahagikan. Per tu bahagi. Jadi dia akan jadi darab dan terbalik. Darab dengan R cube of the M over T square of the M. Yang ni darab atas, ni darab bawah. Okay, darab terbalik. Missing what? TM. Okay. TM square. And then, cube ni pergi sana, dia akan jadi cube root. Okay. Baru kita ganti. Okay. Jupiter punya period 1.88. Jangan lupa square. Lepas tu darab dengan radius of the mass. Radius of the mass is how much? 2.28 times 10 to the power of 11. Jangan lupa cube over period of the mass. Period of the saya silap ganti kot. Not 1.88 ke bawah. Okay. This one is period of the Jupiter kan. Jupiter is 11.9 here. Period of the mass ke bawah. Kena tengok betul-betul. I overlook. 1.88 square. Jangan lupa square. And the whole thing. Jangan lupa cube root. Berapakah jawapan dia?
Wait lah, sir.
Okay.
$7.80 times 10 power of 11.
10 unit.
Unit
Apa yang kamu cari?
radius.
Radius. Jadi SI unit dia? You tak tahu, you cedokkan mass tu lah. Nampak mass? Dia guna apa?
Meter.
Meter lah. Radius tu is a length, right? So meter. Okay, can understand?
Can, sir.
Okay. Kita buat objektif. Tutorial 3.1, 3.2. I'm still chasing after the time. I just need to find the right time to do the discussion. Okay. Okay. Try to do question 1 and question 2 first. Semua compare saja. Okay. And this one, question 1. Mass is a quantity tu padam. Letak tempat kosong, baru letak quantity. Dia salah translate.
Yes, sir.
Mass is what quantity. Macam tu. Okay, do question 1 and question 2 first. Masuk topik apa?
Chapter 4.1.
Which is HIDA.
Yes.
Oh, so fast.
It's very fast.
Very fast. But can you understand our lessons all?
So this one I can understand, but at school my teacher just baca jawapan skema je.
Oh, cikgu apa tu? Nama dia?
Syukur.
Oh, Cikgu Syukur. This Cikgu Syukur ni dia memang dia ada banyak knowledge, tapi dia tak tahu deliver the thing.
Dia pandai tapi
dia memang kadang-kadang dia ada setengah orang dia ada knowledge tinggi tapi dia tak tahu nak bagi orang faham. Dia memang kalau kelas kamu Cikgu Syukur, you need to understand from your tuition teacher. That's a must. I'm still dealing with the Form 5 students this year one. Their
Hmm.
teacher also Cikgu Syukur. Cikgu Syukur
Oh.
ni cikgu yang lama. Sebelum saya belajar dekat high school pun dah ada Cikgu Syukur.
Oh.
Dia memang cikgu yang paling berpengalaman. But if you have any doubt, if you go and ask him any material, he will help you out. He's very
Oh.
kind.
Okay.
But this only thing is he don't know how to make people understand the topic. It's okay. But I will move little bit slower. Is it okay?
Oh, it's okay, sir.
Okay, alright, alright. Okay, do first. Chang. Okay. Mass is a what quantity?
Base quantity.
Mass is a base quantity, boleh atau base atau derive. Kalau kamu nak cakap dalam skala or vector pun boleh juga. Daripada mana-mana combination lah. Alright. Skala pun saya terima, base pun saya terima. Okay, next one. Compare the mass of satellite M1 and M2.
Mass of satellite M1 is equal to M2.
Betul. Saya tulis simbolik M1 is equal to M2 tapi ayat kamu mass of satellite M1 is equal to M2. Must be bentuk ayat lah.
Hmm.
Okay? Right. Compare the orbital radius of R1 and R2.
Orbital radius of satellite R1 is longer than that of R2.
R1 longer.
R2 longer.
R2 longer than R1
Hmm.
Okay. The orbital radius of satellite R2 is longer than R1. Okay, don't write symbolic answer. This one just I want to go fast. Compare the orbital period S1 dengan S2.
S2 is longer than S1.
Yeah, S2 is longer than S1. Relationship between orbital radius and orbital period.
When the orbital radius is longer, the orbital period is also longer.
Okay, longer. Kalau radius kan, kalau baik kamu cakap bigger.
Okay.
When the orbital radius is bigger, then the orbital period is longer. Or bigger the orbital radius, longer the orbital period. Okay. Right. Yang ini related to what law?
Kepler's second law.
Di sini kamu terperangkap. Ini dia orbital radius dengan orbital period. Nampak tak? T dengan R saja. Jadi, betul ke? Second law.
Third law.
Kepler's third law. What will happen to the orbital period if the mass of the satellite S1 increase?
Decrease.
No, it won't change anything. Okay, kamu tengok. Orbital, dia tanya apa? What happened to the orbital period kan? Okay, T square is directly proportional to the R cube only. Does the mass influencing it?
No.
So what happened to the orbital period?
Same.
Remain unchanged. Or same. Okay, why? Because orbital period is not affected by the mass of satellite. Or kamu boleh cakap orbital period is only affected by the orbital radius, not the mass. Okay? Right. Question 2. What is the shape of the orbit?
Elliptical.
Ellipse. Ellipse is the shape. Kalau elliptical maksudnya berbentuk ellipse. Can lah, I accept. Elliptical. Kalau ditanya shape saja, baik jawab ellipse. Compare the area covered by FAB and FCD, sorry.
Area covered by FCD is area covered by FAB is greater than area covered.
Sudah salah. Ini kena ambil Kepler's second law. Kalau Kepler's second law, ingat
Equal.
Time dia kena equal, area pun kena
Kan kena
equal.
ikut.
So area of FAB should be equal to area of FCD. Ayat kamu kena kena berbentuk dalam ayat. Okay.
ஆனால் பெருசும் சிறுசாகவும் இருக்குல்ல.
அது அது பிரச்சனை இல்லை. அது பெருசா சிறுசா இருந்தாலும் பிரச்சனை இல்லை நம்மளுக்கு. ஏன்னா வந்து this one also radius, this one also radius. அதனால
ஓகே ஓகே.
we assume it's a circle நம்ம சொல்லியிருக்கோம்ல.
ஆ
That's why. Okay. And then compare the orbital length AB and length boleh different. Ingat untuk Kepler second law, dua benda kena sama. First is the area, second is the time. Time சொல்றதோட அந்த the time taken to move lah. Betul lah time lah. So compare the orbital length of AB and CD.
orbital length of CD is greater than orbital AB.
CD is greater. But this one is just a small angle only what? This one is just a minor arc. This is the major arc, correct? So AB greater than CD actually.
orbital length வந்து சன்னுக்கும் பிளானெட்டுக்குமா?
சன்க்கும் பிளானெட்க்கும் இல்ல orbital length வந்து இது அவங்க தான் சொல்லியிருக்காங்களா orbital length AB dengan CD, சன்க்கும் அதுக்கும் இல்லை. இந்த இது length
ஓகே
the
ஓகே.
arc. Okay.
ஆ
So how about the linear speed?
so linear speed AB greater than CD.
Yes, because length இது கூடியா இருந்துச்சுன்னா அது அப்படின்னா என்ன அர்த்தம்? Distance AB கூடியா இருக்கு. அப்ப அதோட linear speedம் கூடியா இருக்கணும். So linear speed AB should be greater than linear speed CD. What is the relationship between the time taken and the area covered by both area?
Same.
Yes, same. Just now I told you, right? Area and time are same. So the time taken and the area covered for both area are the same. What law?
Kepler second law.
Kepler's second law. Okay, final question. Okay, kita tengok calculate the orbital period of the planet. Maksudnya dia tanya T itu berapa. If the average distance from the center to the sun to the orbit, the average distance from the center from blah blah and to blah blah is actually the orbital radius R. Sunோட mass கொடுத்திருக்காங்க M and G கொடுத்திருக்காங்க. Okay. So அப்ப T, M, R, G இதெல்லாம் இருக்குன்னா it is not the Kepler's third law that normally we use. Okay. T square is equal to KR cube. The K க்கு நான் வந்து ஒரு கான்ஸ்டன்ட்க்கு ஒரு வேல்யூ சொல்லிருப்பேன்ல 4 pi square G M R cube. Lepas tu square tu kita buang ke sini. 4 pi square R cube over GM is equal to T. So kita ganti semua. Pi tu ganti calculator punya pi Radius, orbital radius is 1.5 times 10 to the power of 11. Sini pi square jangan lupa. Lepas tu R cube jangan lupa. Lepas tu G dia 6.67 times 10 to the power of negative 11. Lepas tu mass of the earth mass of the sun, 1.99 times 10 to the power of 30. And then don't forget to square root it. What do you get?
1.00127.
I get.
Oh, I cube it. Supposed to be square root.
Square root பண்ணணும். 4 times pi square times 1.5 power 11 cube divided by 6.67 power negative 11 1.99 power 30 is, so I'm getting around 3168307.28 seconds.
Same, sir.
சேம் இப்படி தான் கிடைக்கணும். ஸோ இது வந்து நம்ம செகண்ட்ஸில் சொல்கிறோம், டசன்ட் மேட்டர். அவங்க அதான் வந்து ஸ்டாண்டர்ட் யூனிட். ஸோ அவங்க டேஸ் இயர்ஸில் கேட்டிருந்தா நம்ம இயர்ஸில் கொடுக்கலாம், அவங்க கேட்கல, அதனால நம்ம செகண்ட்லேயே கொடுத்துடலாம். ஸோ இது கொஞ்சம் நம்ம ஸ்டாண்டர்ட் ஃபார்மில் மாற்றிப்போம், பிகாஸ் dia punya ni banyak kan. So 3.17 lah. Saya ambil 3 significant figure. Okay, lepas tu times 10 to the power of, okay, இங்க இருக்கணும். இப்போ நம்ம இது மின்னுக்கு கொண்டு போயிட்டோம் இங்க. So 1, 2, 3, 4, 5, 6, 7. Power 7 second. This is how you express the answer. Okay?
Okay, sir. That's it.
Okay. கரெக்டாக நான் 10 நிமிஷம் லேட்டு, 10 நிமிஷம் நம்ம லேட்டாக முடிக்கிறோம். Okay. I stop here. I will do the discussion video on the remaining exercise.
Okay, sir.
Okay.